We're going to use the definition of the derivative to differentiate f of x equal to the square root of cosine of x. Now this was done in an earlier video. We'll do this again here using a different technique, namely a different trig identity. Here are the results we'll need. We'll need the following trig identity. Cosine alpha minus cosine of beta is equal to minus 2 times sine of alpha plus beta over 2 times sine of alpha minus beta over 2. And the second result we'll need limit as y approaches 0 sine of y over y equals 1. So now we can proceed. Recall the definition of the derivative f prime of x is the limit h goes to 0 of f of x plus h minus f of x divided by h. And in our case, this becomes the limit as h approaches 0 square root of cosine of x plus h minus the square root of cosine of x divided by h. Now, first step for us is to multiply the numerator denominator by the conjugate of the numerator, that is the square root of cosine of x plus h plus the square root of cosine of x. And of course this is divided by itself, square root of cosine of x plus h plus the square root of cosine of x. Now what this does, it's going to eliminate the radical in the numerator. This now becomes the limit as h approaches 0, just cosine of x plus h minus cosine of x, and the denominator is h times the square root of cosine of x plus h plus the square root of cosine of x. Now we can apply result number 1. We call x plus h alpha and x beta. This is cosine alpha minus cosine beta. We can apply the trig identity here. So the new limit is going to be limit as h approaches 0 minus 2 times the sine of alpha, which is x plus h plus beta plus x over 2 times the sine of alpha x plus h minus beta, that's minus x over 2, and the denominator is h times the square root of cosine of x plus h plus the square root of cosine of x. So now let's simplify this before we go on. This can be rewritten as the limit as h approaches 0. We have minus 2 times the sine of 2x plus h over 2 times sine of, once x is canceled, it's just h over 2, and this is divided by h times the square root of cosine of x plus h plus the square root of cosine of x. Let's write this as a product of two limits. The first limit will be, so this is a limit h approaches 0, minus 2 sine of h over 2 divided by h, and the second limit is limit h approaches 0 of, we have sine of 2x plus h over 2 divided by the square root of cosine of x plus h plus the square root of cosine of x. Now what we have to do right here, I'll multiply the h by 2 over 2. It didn't change anything. I can take the minus 2 here, just a 2, and cancel with the 2 from the numerator. And now we're left with the following. The minus sign can be, or minus can be filtered in front of the limit. So this is minus limit h approaches 0. We now have sine of h over 2 divided by h over 2, and we can now evaluate the second limit. As h goes to 0 inside the sine, we have 2x over 2, which is x, so that's sine of x. And the denominator is the square root of cosine of x plus the square root of cosine of x. Now here we'll make the substitution. Let y equal to h over 2. We note that as h goes to 0, so does y, and we can rewrite this as minus the limit as y goes to 0 of sine of y over y, and then of course the second limit is computed already, that's sine of x, divided by 2 times the square root of cosine of x. Now by result number 2, this limit is 1, so the answer is going to be minus sine of x divided by 2 times the square root of cosine of x. And let's summarize this. If f of x is equal to the square root of cosine of x, by definition we just derived the derivative f prime is equal to minus sine of x divided by 2 times the square root cosine of x. For more videos, visit www.mathprepvideos.com.